All right, let's jump right into this explainer. Good teaching requires a level of attention that is honestly incredibly difficult to sustain. We're talking about reading a student's mind, spotting the exact missing prerequisite, and then somehow choosing the perfect next move. But today, we're facing a real modern crisis in education. In an age where an AI can generate a fluent, perfect-sounding answer to almost any prompt you throw at it, the most valuable thing isn't the answer itself anymore. Nope, it's actually proving that a human being has genuinely learned something. And this brings us to a rather existential question for our classrooms right now. When a machine can answer literally anything, how do we prove a human has learned? Think about those overwhelmed teachers looking out at crowded classrooms. They simply cannot read every single student's mind to verify true, deep understanding. It's just not possible. Section 1. The verification problem, a modern crisis. Let's look at the traditional learning management system, or LMS. It really just tracks basic activity. What file was opened? What quiz was submitted? It's a simple completion metric. I mean, if you've ever just rapidly clicked next, next, next to rush through a required online training, you know exactly what this looks like, right? But on the flip side, we have the oppositional learning management system, or OLMS. This is designed to track verifiable mastery and the actual reasoning behind a learner's answers. Because think about it. On a traditional progress bar, a lucky, completely random guess looks absolutely identical to deep, profound understanding, right up until the very next question separates them. Which brings us to this really defining quote. OLMS is built to oppose the learner's false assumptions and unearned confidence. It targets error, not the person. Now, I know the word oppositional sounds a bit hostile, right? But it's actually incredibly helpful. It's not about being mean or overly strict. It's about highly collaborative, Socratic probing. It fundamentally prevents students from coasting on familiar-sounding answers without truly grasping the mechanics underneath. Section 2. Oppositional learning, a new paradigm. So, the absolutely crucial point here is this concept of oppositional questioning. You see, OMLS doesn't just take a right answer at face value. If you get the answer right, the system immediately pushes back and asks, wait, why does that work? Or, what breaks if we change this specific variable? It treats a correct answer not as a final proof that you know the material, but as a claim that needs to be actively tested to expose any deep-seated misconceptions. The real secret to this is a continuous control loop. Let's break it down. Step 1, the learner interacts, which produces evidence. Step 2, that evidence instantly updates their mastery estimate. Step 3, a counsel engine analyzes all of those current estimates to pinpoint weak spots. And finally, Step 4, the absolute best next action is selected specifically for that student. This loop is what drives true, dynamic, personalized learning. It moves us entirely away from that rigid, one-size-fits-all syllabus that always ends up leaving people behind. Section 3. Tracking real mastery. Beyond the guess. First up, we have the mastery estimate. Think of this as a continuously updated, highly revisable value between 0 and 1. It constantly moves up and down with every single piece of evidence a student provides. But here is the kicker. This is explicitly not a final certification of mastery. It is just an ongoing estimate of where the student currently stands. To actually earn that discrete mastered label? Well, the knowledge has to clear a very high bar. It must be operational, meaning the student can successfully apply it to a completely unfamiliar instance they haven't ever seen before. And it must be accessible, meaning they can retrieve it from memory entirely unaided after a time delay. So the big takeaway here is that absolutely nothing passes silently into the record as known without clearing this incredibly strict bar of transfer and retrieval. Which naturally leads us to a massive, highly practical question. Wait, but how? How does a machine actually know what concepts build on each other across entirely different subjects to guide this whole learning loop? Section 4. Knowledge Graph Engine, the encyclopedic spine. Well, this is exactly why linear curriculum paths fail so often. OLMS uses something called graph-first sequencing. It traces prerequisite dependencies backward. So let's say a student is really struggling with long division. The graph might reveal that the actual problem isn't division at all. It's a missing foundational concept way back in place value. Sometimes a learner literally needs to move backward or sideways to patch a gap, and fixed linear sequences just do not allow for that. To pull this off, the system needs data. Lots and lots of data. 120.7 million. That is the awe-inspiring number of total items currently sitting in Wikidata as of late 2025. It's a number that really anchors the sheer, massive scale of structured, decentralized data required to map out all of human knowledge for a system like this to navigate effectively. Section 5. Merging Universal Data, the Tripartite Foundation. To manage all this, the universal knowledge ecosystem relies on what we call a tripartite foundation, basically 3 pillars. First, we have Wikidata, which provides real-time, massive, emergent scope. Then we have Dpedia, acting as the central, carefully curated interlinking hub. And finally, we have Yago 4.5, which provides strict, logical consistency that's directly mapped to schema.org standards. Together, these 3 encyclopedic graphs literally anchor the factual reality of the entire system. But how does this work with actual human language? Humans are messy. We have those rigid, factual encyclopedic spines we just talked about. But to understand human nuance, we have to layer on common sense networks, things like ConceptNet and WordNet. The industry relies on the Common Sense Knowledge Graph, or CSKG, to consolidate all these sources and resolve the really weird heterogeneities in how humans actually speak and relate concepts to one another. The result of combining these highly structured graphs with large language models is called agentic semantic intelligence. The industry has really shifted toward frameworks like GraphRag, which essentially uses knowledge graphs as the actual brain for the AI. By using tools like Plumber and agentic entity linking, the AI interactively probes these graphs to ensure a staggering 95% semantic alignment. This radically reduces AI hallucinations and enables incredibly high factuality. In short, it means the AI stops making things up and strictly follows the facts. So, bringing it all back to education, OLMS takes all that massive, complex, universal data and brilliantly distills it. It maps everything into a highly controlled vocabulary of just 12 canonical relations, simple things like prerequisite, builds on, or specializes. This takes the complete chaos of global human knowledge and turns it into clean, practical, dependency-driven learning paths for anyone trying to master a complex subject. Section 6. A trustworthy future. Verifiable education. Now, while the core architecture for evidence aggregation and graph sequencing is largely built, getting to a fully trustworthy certification system requires us to hit some major benchmarks. We need complete validated coverage of subjects. We absolutely need predictive validity, meaning the system's ready label actually predicts real-world exam success. And features like spaced repetition scheduling are actually still on the research roadmap before we can achieve true, verifiable per-node mastery. So we're getting there, but there is still work to do. Which leaves us with one final, deeply provocative thought as this technology matures. The architecture for an AI-driven paradigm shift in verifiable learning is absolutely arriving. But are our institutions, our schools, our professional licensing boards, our society as a whole, are we truly ready to trust machines with our final certifications?